there's no way to write a shorthand for orbital notation. Okay? There might be, but there's no acceptable way. Let's put it that way. Okay? So when you're doing orbital notations, you have to do the whole thing all the way out. There is a shorthand way of writing electron configurations, however. All right? And that's what I'm going to teach you next. Now, electron configurations are easy once you do orbital notation. But once you learn this, then we should be able to write a shorthand version. To do that, we need to figure out a place to sort of begin. And what we're going to do is we're going to begin with noble gases. Now, if you didn't know this or you don't remember this in physical science, everything in this last column of the periodic table are known as noble gases. Everything over here all these are known as noble gases. So these are the noble gases. Okay? Noble gases. Now,
can we use another one of these charts?
No, we'll get to that. We'll actually label them with noble gases later, but you just need to know it. I'm just telling you right now that's what they are.
So where's
Okay?
the top at?
Well, let's hold on and look. Now before we just hang on. When we get to bonding, and that's our next unit. Unit 3 is about bonding. Okay, when we get to bonding, we're going to find out that only the electrons that go beyond this point here are involved in the bonding. Everything from here back doesn't do anything with bonding at all. Okay? Well, from here back matches up with the electron configuration of another element. And that other element would be krypton. So let's write out krypton here for a minute.
Mine just broke. My lapis.
Okay, so that's one of the noble gases. Here's krypton. It's the next lowest noble gas from silver. So if I take and look at silver, and I count back, here's 47. Get your periodic table out if you don't have it, and just count your way back. 47, 46, 45, 44. Put your finger on it and physically count it till you get back and find an element that's in this last column on the right. And you come to krypton. Okay? And we're not talking about the krypton in the Superman comics here, all right? This is krypton, the gas. So this is the orbital notation for krypton. But let's look. All of this electron configuration matches this part of silver's electron configuration. Okay? They're the same, aren't they? All right? And all the action takes place in chemistry after that, up here. So if we could write this electron configuration where all we're really showing is that's all we really need as far as looking at how elements combine with each other. Okay? So here's what we do in the sciences. Looking for my red marker. Very often, what we're going to do is we're going to have two different kinds of electron configurations. And what we're going to do is we're going to take this part right here, and we're going to replace that part with this symbol for krypton. Okay? So instead of writing all of this, we're going to write it like this. Silver, hit the symbol. Then we're going to put the symbol for krypton in brackets. That has to be there. You can't just drop it out entirely. You have to tell me what you're building on top of. By writing that there, we're saying that we're including all of krypton's electron configuration. But then on top of that, we're going to write 5s1 and 4d10. And that's a shorter version. Okay, a shorthand version or a noble gas configuration. Yeah. All of the action takes place in bonding from here up. Okay? Basically, this part of silver right here isn't involved in bonding at all. Well, this part isn't. We don't. When we do bonding, the only electrons we move around in bonding are these up here. We don't move these at all. So since that's the case, we kind of take and condense this long electron configuration to replace this part of it with the symbol for krypton, because that's what that electron configuration is. That's the configuration for krypton right there. Okay? So by replacing it with that Kr symbol in a bracket, we just show the part that really matters in bonding. Zach? That's you have to be able to do both of these. Yep.
What happens when two smaller elements, or not smaller, but elements with smaller orbital notation, whatever, bonds, because they don't have that ending part in the green?
Well, all of them except hydrogen and helium would. Let's try it. Let's see. Okay. Let's do another one in a minute. All right. We'll do another one.
5s1.
5s1. When you say smaller, is oxygen small enough?
I guess, yeah.
Oh, well, I'm just asking you.
Oh, yeah.
All right. Let's do the same thing for oxygen then.
Can you show me how you did this? Because my pencil is getting broken. I didn't. Okay, keep going. Never mind. Let's go.
You like the long way better? Well, but you need to know both. Okay. All right. So let's just do oxygen. All right. We're going to do the orbital notation. We're going to do both kinds of electron configuration for oxygen. Okay. So here's oxygen. Oxygen is located right here. You all need to be working on this. Everybody needs to be working on this. This isn't free time. It's chemistry class, folks. All right. So there's oxygen, and we start with 1s. Okay, and we're going to get up to oxygen. So 1s is full. 2 electrons. Then we get to 2s here. And since oxygen is over here, 2s is going to be full. But 2p is not going to be completely full. 2p has to have 3 boxes for 3 orbitals. But we only need 1, 2, 3, 4 electrons in 2p. Okay? So 1, 2, 3, 4, and that's where we stop using the school bus rule. Okay? So now we can write the full electron configuration. 1s, 2 electrons, 2s, and 2 electrons there. 2 arrows mean 2 electrons. And then 2p, 1, 2, 3, 4. Okay? So that's the full electron configuration. All right, now put your finger on oxygen here on your periodic table. Okay, sorry. I'm moving too fast for you?
A little bit out of right.
Okay. So you broke Nate's pencil and you're writing too slow. Okay, I got it. All right. I don't know. I was just joking. I don't know. You're talking.
Mine broke and I was.
Okay. It's okay. All right. All right. So put your finger on oxygen. Put your finger on oxygen, and that's element number 8. Count back till you come to a noble gas. Count backwards till you come to a noble gas. Well, 1 is hydrogen. That's not a noble gas.
No, I was saying like
Oh.
going back. 6.
1, 2, 3, 4, 5. There we are. Now we're at a noble gas. Huh?
This is
All you got to do is go back to the next.
Nitrogen was a noble gas.
No. Everything in the right column is noble gases. All the way over there. Okay? All right. So helium has a configuration of just simply 1s2. So the only part of oxygen's electron configuration that we can replace is just that part right there. So to write the noble gas sort of arrangement,
So it'd be O, cold, bracket, A2, 2N, 2S, 2 people.
that's it.
2s what?
Okay?
Like you said, it's pretty much you write whatever they don't have in common, right?
Yeah. It pretty much whatever the two of them don't have in common. The next lowest noble gas and the element you're working
What's
with
this
is true.
called?
I usually call it the shorthand version of the electron configuration, but it has another name I'll get to later. Okay? You want to do one more? Well, now, here's what I'm getting to with this. This doesn't really save you much from this, does it? They're about the same. But when we get to the larger things, then it makes it a lot easier.
Like you would go from like silver back to like oxygen.
Well, let's do it. How about we do aluminum?
Alright.
Want to do aluminum? All right, everybody do orbital notation in both kinds of electron configuration for aluminum. Let's practice that one. Okay?
Hold up.